Hey AP Calc, this first video out of two is going to cover all of the problems that you guys asked about from the sample assessment and some from the in-class packet that are not inverse derivative problems. I'll have a second video on all the inverse ones, and I'll explain that in the next video. So let's get started right away. For number 16 in the sample assessment, we have a definition of derivative problem. And you'll notice that this is the h approaches 0 version. So it's a really good idea to sort of write out the original, more formal definition. And I'll actually just write it out here. F prime of any function is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, this problem is a little bit different than normal because it actually has numbers instead of x's. This is okay. You can use the original definition of derivative at a point. So really, this is saying we have cosine as f of x, cosine as f of x. And the reason we know this is because where there's an f of x plus h, it has a cosine instead. Now, you might be wondering, well, why is there a pi over 3 instead of an x? That's because the problem is asking us evaluate for pi over 3. Now, we have that cosine of pi over 3 is 1/2. We know that. Well, we just found that whatever f of pi over 3 is, that's on the right there, where it says minus 1/2. Well, that must mean this problem is really asking us, what is the derivative at pi over 3? Because this is the definition of derivative, and there's a cosine in it. Well, fortunately, we know how to do that definition of derivative already, but without the definition. Let's just do trig. F prime of x equals negative sine of x. And it's saying, what is f prime of pi over 3? So f prime of pi over 3 is negative sine of pi over 3, which is, well, now we're going to match it up. Well, sine of pi over 3 is root 3 over 2, but it's the negative version. So we're going to choose B, negative root 3 over 2. So for these definition derivative problems, my suggestion is to extract out what the original function is, and then figure out what the x value is, pi over 3, and do the derivative normally. So there we go. It's letter choice B. Let's keep going. These are in a little bit of a random order, so just bear with me. I'm going to go on to the next slide here. Okay, so we have number 17 then. This is an implicit problem. It says do the second derivative of that. All right, so here we go. We got 2x plus 2y y prime because of chain rule, because the variables don't agree. We are doing d dx, and there's a y there. So it's got the extra y prime equals 0, because the derivative of 6 is 0. And then we want to solve for y prime. So let me throw over the 2x and divide by 2y. We're going to have y prime equals negative x over y. All right, so it then wants us to take the second derivative. So instead of just writing y double prime, I'm going to use the notation that it has here. D squared y over dx squared equals. We have negative and then a quotient. So let me do negative low d high, high d low, low low. So low d high minus high d low y prime over low low. All right, so we are just going to play the matching game now after I do a quick substitution. So I have negative y minus x, and y prime, we just figured out it was negative x over y squared. At this point, what we need to do is we need to do a little bit of algebra. We need to do a little bit of algebra just to match it up with one of these terms. Okay, so how do we do this? Well, it looks like I can do common denominators. I think I'm going to need to do a little bit of scratch work. I'm going to do negative y squared over y plus x squared over y all over y squared. Ooh, that got a little gross. What are you going to do? Okay, so the reason I did that is because in the numerator of this expression at the bottom, the numerator of that did not have common denominators. So I multiplied that original y by y over y to get that. So this is equivalent to negative y squared plus x squared all over y squared. And that right there a little more clearly matches up with E. Once we just do a sort of a quick little throw the y squared and the y together to make that y cubed. All right, there we go. Let's move on. All right, we have another derivative problem, and this should be pretty clearly a product rule. We have two functions of x multiplied together, and it says, hey, take the derivative of that and then match it up with one of the answer choices. So 1 d2, bring down the 1/2, inside stuff stays the same, 2x minus 3, all to the negative 1/2. This is chain rule here. So I brought down that square root as the 1/2 and power ruled it, but the derivative of the inside is 2. So that was 1 d2. 1. All of that is d2 plus 2 d1. All right, there we go. At this point, we are technically done. However, this clearly doesn't look like one of our answer choices. So let me clean this up a little bit. I see that my answer choices have all square roots. So let me rewrite this negative 1/2 exponent as the following. 2x all over 2 to the root 2x minus 3. And the reason I did that is because we have a negative 1/2 as the exponent. That means we have a positive square root in the denominator plus root 2x minus 3. All right, so I need to somehow figure out how to make all of that match up with one of my answer choices. Let me do this. Let me multiply this term right here by root 2x minus 3 all over 2x, root 2x minus 3. What that's going to do is it's going to give me the following. Also, let me cancel those 2's. I've got x over root 2x minus 3 plus those square roots cancel, so I'll just have 2x minus 3 all over root 2x minus 3. And we now have common denominators. So we have an x plus 2x's. That'll get me 3x's minus 3 all over root 2x minus 3. And what does that match up with? Boom, B. All right, so that's a little fancy schmancy. This problem, because we noticed that all of our answer choices had only one big fraction. That was an indicator that we really needed to use some algebra 2, namely multiply by fancy 1, so that we could get common denominators. This is 2 problems in a row where we had to do common denominators to play the matching game. That happens sometimes. Anytime you have 2 terms in your work, but only one big term in your answer choices, that is an indicator that you need to go back to your Algebra 2 skills to figure out a creative way to combine. Let's keep going. All right, so we had some questions about logarithmic differentiation from the in-class. I'm going to focus right now on the number 5. We have sine to the x. anytime you have an x in the exponent, let's take the ln of both sides. I'm actually going to do my work up here. So we have ln y equals x ln of sine x. All right, then a derivative. We have y prime over y equals. We have functions of x where x is my 1 and ln of sine is 2. So we have 1 d2, and 2 is an ln function. Every ln's derivative is u prime over u. So u prime over u, because the derivative of sine is cosine. So that's u prime over u, plus 2d1. That's ln of sine x times 1, because that's the derivative of x. So I'm just going to leave it like that. And then I'm going to throw, I don't know why my y is doing that. I'm going to throw my other y over. So x, cosine x over sine x is really cotangent x, plus ln of sine x. All of that gets multiplied by my y, which is sine x to the x. And we're good to go there. All right, so I believe that was the only question that was actually asked on this in class. Let's keep going here. See if we got anything left. Nope, it looks like that's it, except for the inverse trig. I hope that you guys found that really helpful. Continue to ask questions on that kind of stuff, because some of these are a little doozy.